3分ほどでセッションが開始されますので、Okay, so please have a seat. It's time to start the session. The next session title is I'm Still Using Python 2, Should I Be Worried? By Sebastian Witowski. Yeah, please welcome Sebastian with applause. And take your seat after test of mic. Please every day listen carefully.
My name is Sebastian Witowski. The title of my presentation is It's 2019 and I'm still using Python 2. Should I be worried? The presentation material are in English and my presentation will be in English as well. I consent to being recorded during my presentation. I consent to having my picture taken during my presentation. I will comply with the PyCon Japan Code of Conduct. 皆さん、こんにちは。ウィトフスキー・セバスティアンと申します。私はポーランドから来ました。今年の3月に初めて日本に来て、桜の国を好きになりました。だからもう一回ここに来て、皆さんの前で発表して、本当に嬉しいです。So I would love to be able to tell the whole presentation in Japanese, but it's not today, maybe next year. So hi, just before we start, here are the slides for my talk. I will have a lot of links, to other resources, so it might be easier for you to download the slides or to follow them on your computer. Also, here is my Twitter handle, and there's my website that has a contact form. So if you have any questions or comments and you don't manage to catch me during the conference, that's the easiest way to get in touch. So hi again, I'm Sebastian. I write Python code for a living, and I also teach others how to write Python. And in my spare time, I love to talk about interesting problems. And the end of life for Python 2 is an interesting problem. Although maybe not for those of you who still have thousands of lines of Python 2 code that needs to be migrated. So how many of you are still using Python 2? Hands up. A few hands. And how many of you are planning to migrate to Python 3 by the end of this year? Like, still a few hands, okay. And last question, who here knows for sure that he or she will still be using Python 2 in year 2020? Perfect, 2 hands. 3, great. So I can actually continue. Well, it's not great for those of you who still will be using Python 2 in 2020, but it's also not as bad as it sounds. So about this talk. This is not how we migrated to Python 3 at foobar company type of talk. There are already 500 talks and blog posts on this subject, and they are all more or less similar, so I'm not going to repeat them. This talk doesn't focus purely on the migration to Python 3. I will talk about the migration, how to prepare, what to use at the end, but this is not the main focus. What I would like to talk first are the risks of staying on an unsupported Python version, what solutions do you have, and finally, what are the important things to consider if you decide to migrate. So Python 3 has been out since December 28, but there are still projects that are using Python 2. Why? Well, there are a few reasons I can think of. First, the cost of migration can't be justified from a business point of view. As developers, we understand that since a few years, every line of code that we write in Python 2 is a technical debt. But it's not developers who run most of the companies. We all have managers that make decisions based on what's the value of each project, what value this project brings to the company. And the fact that the programming language is becoming obsolete in a few months, it's quite often not good enough reason to spend resources on migrating. The thing is, rewriting Python 2 to Python 3 does not bring money for the company. I have never seen a product that advertises that it's using Python 3 on its landing page, well, unless it's a product for developers. And there's always a new feature waiting to be added to the product, or there is an urgent fix that needs to be deployed. So there are two things that many managers won't agree to do. Set aside some time to do refactoring and to rewrite an application that is working just fine. When it comes to refactoring, you can always do this in small increments following the Boy Scout rule. So the Boy Scout rule means that you should leave the place in a better shape than how you found it. So when you're adding a feature to a function, you can always clean up this function a bit. But there is no way to migrate Python 2 to Python 3 application in small increments. Well, technically there is. You can always start writing code that is Python 2 and Python 3 compatible. But you will still have to migrate the old code base that no one has touched in a very long time. Which brings me to my last point. Migrating an old code base can be scary. Imagine you have some code that was written by a person who left the company a long time ago. And of course, there are little or no tests, and documentation is very poor, often outdated, if you're lucky and there is actually any documentation. The code works, so it's fine. But no one has any idea how the code works. So no one has been touching this code since years. It's a scary thought that at some point you will have to rewrite it so the code stays on Python 2. So migration will take a lot of resources and development time. And in return, it probably won't implement any new features, right? Well, that's actually the whole point of migration. Do not try to migrate and add new features, even just small improvements, because it will make your migration even harder. It's much easier to migrate first and then to add the features. And in the worst case, adding features during the migration will compromise the whole migration, leaving your code in a total mess that you will never be able to recover from. But that doesn't mean the migration won't bring any value to the project. First of all, you won't be using an unsupported Python version in a few months. I will tell you in a moment what this unsupported really means. And Python 3 is faster than Python 2, or at least as fast as Python 2, depending on your use case. And each new release of Python 3 introduces new improvements. Here's an example from the release notes that dictionaries in Python 3.6 got a significant memory improvement. So simply staying on the latest Python version will let you benefit from those improvements. Switching to Python 3 will let you use the new features of the language, like the async I/O, the type hints, ordered dictionaries, the sweet new f-strings, the better Unicode behavior, and more. And your dependencies are probably already on Python 3, and they will stop supporting Python 2 pretty soon. So there is a website called Python 3 statement. It was created as a call to action for many Python projects to stop supporting Python 2 from the next year. As you can see, there is quite a lot of big projects there, and each of them declared that starting from January 2020, they will no longer support Python 2, which means that there won't be any updates for your dependencies, and that includes security fixes. So not only there might be some vulnerabilities in the old versions that you are using, but you also won't be able to use the latest features of your dependencies. So there are many benefits of migrating, and if someone tells you something different, show them this slide. And you know what? Now is actually the best time to migrate. Here is why. Unless you have some very obscure dependencies, there is a big chance that all of them have already been ported to Python 3, which was not the case a few years ago. Here is a website called Python 3 Readiness. It shows that all 360 most popular Python packages support Python 3. Migrating in the first few years after Python 3 was released was hard or even impossible, because most of the dependencies were still on Python 2. But this is no longer a case. So if your dependencies are not yet ported to Python 3, I'm pretty sure they will never be. So you should start looking for a replacement. Also, automatic tools that can help you with the migration has been already tested by thousands of other developers. There won't be any better tools coming out soon. And many companies already went through the migration. They often write and talk about that, so you can learn from their mistakes. Have friends in another company that's using Python? Great. Just meet them and ask them about the migration. Don't have friends? Don't worry. Almost every Python conference in the past few years had at least one talk about the migration. So just check out the YouTube videos. So here are some examples. There is an article from Dropbox about migrating their code base to Python 3. But the creator of Python, Guido van Rossum, is working at Dropbox, so he probably rewrote everything like 1 or 2 afternoons. There is a really good porting guide by Brett Cannon that explains how to prepare to the migration. And finally, there is a keynote from PyCon 2017. The video on YouTube is just called PyCon 2017 keynote, so you will never find it if you search for migration or Python 3. But the keynote is actually given by the tech leads from the Instagram, and they discuss how they migrated the platform that is being used by 7 million people from Python 2 to Python 3. It's a really good video explaining what decisions they took during the migration and what were the main problems they encountered. And it has a good sense of humor, so it's also fun to watch. And finally, Python 2 is still supported, so you have those 2-3 months of runway on Python 2. The end of life for Python is set for the 1st of January 2020. There is even a website called Python Clock that shows you a countdown. Is it gonna work? Is it? No. Okay, that was supposed to put a live iframe. Okay. So what will really happen in a few months? Will someone pull the plug on Python 2 and your projects will stop working? Well, not really. The only thing that will happen is that there will be no more bug fixes for Python 2. So on January, the 2.7.18 version of Python will be released, and that's it. According to the comment from Guido, the core developers are tired of supporting Python 2, and it will stop receiving the support from the core developers, the Python Software Foundation, and the Python.org. This statement is from the time when Guido was the BDFL, and now we have a steering community, but nothing has changed in that subject. Which means that if there is a zero-day exploit for Python 2 in January 2020, there might be no one to help you. You won't get support from Python community, but you might get support from a commercial vendor. Take, for example, Red Hat. In June 2014, Red Hat published Red Hat Enterprise Linux 7 with Python 2.7 as the system Python. And based on Red Hat's 10-year support lifecycle, it should receive support until at least 2024. So that could buy you 4 more years of Python 2 support if you need it, at the price of switching from a free and open source programming language to actually paying someone to use their version of Python. I will get back to the commercial vendors again later in this talk. So that was what will happen with Python 2 language in 2020. But what will happen with your project or your application? Well, it could be one of a few things. Nothing. Your Python 2 software will keep working fine. I've been doing software development for long enough to know that this is probably not going to happen, but maybe you're extremely lucky. Or maybe you will be hacked. There will be some vulnerabilities in your system that someone can exploit. And even if you know about them, you probably won't be able to easily fix them. Even if there won't be any issues with Python 2 itself, the thing is, it's not only your code that can be vulnerable. Also, your dependencies can, and the more dependencies you are using, the more likely it is that some of them will have security issues. Or your project will slowly start falling apart, and you will have to keep firefighting to keep it alive. Again, the main reasons are the dependencies and the underlying libraries. Some of them will be removed from PyPI, and some of them will stop working after you update other parts of your system. So what can you do about Python 2 end of life? So ordered from the least amount of effort to the most amount of effort, you can first do nothing. That's the easiest thing to do, as it requires literally zero work from your side. It probably won't work. So you can freeze the state of your application in Python 2. In other words, you can Dockerize it. It won't help you in case of a security vulnerability, but it will help you in case some dependencies will break. And dependencies will break, for example, when someone removes a package from PyPI or GitHub. Do you remember when we all laughed at JavaScript when someone removed a library that pads text left and suddenly the build started failing? Well, that's not only a JavaScript thing. I have seen cases of people removing their Python 2 projects from PyPI. I won't discuss whether it's ethical to remove stuff from PyPI or not, but this happens. And it makes others angry because suddenly their projects are failing. So not only the core CPython developers, but also maintainers of Python packages get tired of supporting Python 2. And maybe one day they will decide to pull the plug, tired of seeing people opening new issues in a project that they decided to deprecate a long time ago. So take a moment and ask yourself, how badly would you be screwed if one of your dependencies disappears right now? So luckily, we have Docker. So write a Docker file that uses Python 2 as a base image. Add all the dependencies and set your application as a Docker image. Finally, push that image to a public or private Docker repository. And now you have an immutable container with your application. So the problem with missing dependencies should be solved. This is a pretty good approach for internal tools that are written in Python 2 and who are not exposed to the outside world. In this case, you can be sure that the app will keep working forever, and you don't have to worry about someone hacking it if it's not connected to the internet. Also, please do this now while your dependencies are working. Don't wait until 2020. Next option is to change the Python interpreter that you are using. So when I say Python 2 in my talk, I mean CPython 2. But CPython is not the only Python interpreter. There is also PyPy, which is a solid alternative to CPython. And since it's actually built on top of Python 2, PyPy is not planning to deprecate it at any point. Don't think of PyPy as a curiosity that no one is using. PyPy is very mature. It's passing the same test suite as CPython. And there are companies that have been using it in production for years. So it's a valid replacement for CPython 2. Here is a link to a talk from PyCon Sweden about using PyPy in production and benefits of doing that. But PyPy won't work in every case. If your project relies heavily on C extensions, then PyPy might not be a good solution for you. But if you switch to PyPy and everything works fine, which you will need to verify with tests, then your app might even run faster than before, which is a really nice side effect to have. There is also this Intel distribution for Python. It's a free Python distribution maintained by Intel that supports Python 2.7 and 3.6. When I spoke with one of the people involved in this project, they assured me that they are also not planning to deprecate Python 2.7 anytime soon. And finally, there are commercial solutions. So one of them is Red Hat Enterprise Linux that I mentioned before. If you manage to get version 7, that should provide you with 4 more years of Python support. And there are also other commercial vendors that you can find on the internet. And quick disclaimer, I'm not related in any way with Intel or Red Hat or any other companies that I'm mentioning here. I decided to talk about their solutions to give you the full spectrum of options that you have. Next option is to maintain your own CPython2 build. It's exactly as tedious as it sounds. So you fork the CPython repository. You wait for the vulnerabilities to appear, you patch them, you compile your own CPython version, and you use this on the production servers. Probably not the best idea until you really know what you're doing. You can migrate your application to Python 3. This is the most common option, but it comes with a lot of work involved. So there are 2 ways how you can migrate. The first one is with straddling code. Straddling code is a code that works with both Python 2 and Python 3 at the same time. It sounds like more work, as you need to support both major Python versions, but it makes the transition easier. There is no sudden switch from Python 2 to Python 3. So you start by running your tests under Python 3. Of course, most of them will fail. And then you keep rewriting parts of your application until it works under both Python 2 and Python 3. Then you switch the Python version in your production, and finally, this is an optional step, you can remove the old Python 2 code. The nice thing with this approach is that you can do this in iterations. So you migrate parts of your system, and you can keep adding new features to your code at the same time. So that can keep your customers happy. The other option is to rewrite parts of Python 2 code in Python 3. It's less work, as you don't care anymore about Python 2. But it means that you have a Python 2 application in production, and you keep working on Python 3 version, you keep testing it, and when it's ready, you pull the plug on Python 2, and you turn on Python 3 version in production, which is scary, because if there are some things that you didn't test, there is no coming back to Python 2. And it also means that you have to stop adding features to your app. Otherwise, you will be doing a double work. You will need to add those features to both Python 2 and Python 3 versions of your application. Finally, you can rewrite your application from scratch in Python 3 or any other language that will work the best. This requires the most amount of work, and it only makes sense if Python 2 was just a prototype. But it lets you completely redesign your application. Okay, so we discussed what will happen with Python 2, what can happen with your application, and what are the possible solutions. Let's talk about the migration. It's the most popular solution, and sooner or later, most of the companies decide to do that. So let's say that you decided to migrate. How do you prepare? The plan for migration is very simple, and I can boil it down to 4 points. First, you need tests. No, seriously, you need tests. Then you check your dependencies, and then finally you migrate. So keep in mind that while I will talk about migrating to CPython 3, those steps can generally apply to migrating also to PyPy or commercial distribution. So you probably noticed I put a lot of stress on having tests. So here's why. If you are still using Python 2, I have a feeling that your project might have a bigger or smaller pile of technical debt. And if there is a technical debt in a project, there are 2 things that suffer first: tests and the documentation. Many of the projects that are not yet migrated to Python 3 are not migrated because they don't have a sufficient test coverage. So there is no way for them to verify that everything works fine after the migration. And not having tests right now makes it even harder to convince management to allow for the migration. Like, hey boss, before we can spend those 3 months migrating our project to Python 3, we also need to spend 2 more weeks writing tests for Python 2. By the way, we will have to migrate those tests as well. It's not something that managers like to hear. So I have 2 pieces of advice here. First, write your tests with code that supports both Python 2 and Python 3. That way you will be able to keep them after the migration. And if you absolutely can't afford to spend time writing tests, and your project happens to be a web application, record functional tests instead. Here is how. You download Selenium. It's a free tool that lets you record yourself clicking stuff in the browser, and it tries to replay those actions. There is an extension for Chrome and Firefox, so you don't even have to install anything on your computer. Next, spend a day or 2 recording your tests in Selenium. Try to record all the possible use cases in your application. Click every button, fill in every form, make mistakes in forms to see the error messages. Use assertions to check if the data was preserved correctly. This is very important, as probably your main problem with the migration will be related to string encoding. And then back up those tests. Add them to your GitHub repository or something. Just don't keep them on your computer if those are the only tests that you have. Step 3, profit. So you just created a decent test coverage in 2 days of work. Sure, those tests won't see the errors that are happening in the backend of your application, and they will be way too slow to run them regularly, but at least you can check that everything your customers see after the migration is working fine. Here's a quick demo of Selenium in action. So I'm creating a test suite. I don't think you can really see it, but yeah. So then I'm going to record myself like clicking links in the browser. Still clicking. Oh, gonna take some water. And then at the end, I'm filling a contact form. And that's it. Now I'm saving this generated test. And now I can click replay, and Selenium will automatically try to replay all the steps that I did. So it's just going to automatically open the browser, click all this stuff. Yeah, I'm switching back so we can see the green stuff is passing. And then at some point, it's going to get stuck because it recorded a mouse hover event, and now it cannot find it. But I don't really care about this event, so I'm just going to delete it by hand. And now I'm going to rerun my tests again. Yeah, and now it's passing. So you can see it's not the fastest thing, and it's also not a perfect tool, because sometimes it makes mistakes, but it's good enough. If you have more time for writing tests and you want a faster solution, there is an awesome tool called Puppeteer. It has become a de facto standard for writing headless tests. So headless test won't open a browser, but it will run all the tests as if the browser was open. And by doing that, it will be much faster. And there are extensions like this Puppeteer recorder that lets you record all the steps in the browser. So using Puppeteer will run tests faster than Selenium, but it will require more time to record those tests. And finally, if you don't have time, but you have money, there are paid solutions like this Test Cafe Studio or Ghost Inspector. They both offer a nice interface for recording your tests, and they have free trials, so maybe you will find them useful. Again, I'm not affiliated with any of those tools, and for my use cases, I have been using Selenium all the time, but now that I found this Puppeteer recorder, I will probably use it next time. And if you have time to actually write tests, focus on 2 areas where you will have the biggest problems. First is the Unicode support, and then division. Why those 2 areas? Well, because instead of crashing your application under Python 3, they will simply behave differently. And it might take you some time to actually notice that you are getting corrupted data. So for Unicode, test the areas where the strings are getting in and out of your application. And for division, just write tests for the functions that are dividing numbers, especially if they have to deal with money. So now that you have tests, I suggest you take a moment and set up Tox. Tox is an automation tool for Python, but everyone I know is using it to mainly run tests under different versions of Python. So you install it with pip, then you create a tox ini file with a very basic settings that specify which versions of Python you want to use. And optionally, I'm also specifying that I want to use PyTest for testing. Also make sure that you have Python 2.7 and 3.7 installed on your machine. And finally, you just run tox command, and it will execute your test in separate virtual environments, reporting errors for each of them. So here is an example of tox report. I'm not sure you can see clearly, but I have a test that's using a print function in my code, so it won't work under Python 3. And indeed, the tests for Python 3 are passing, and I'm getting an error under Python 2. So the next step is to check your dependencies. It's better to know what's their status before you start the migration. If you're using the popular ones, there is a huge chance that they have already been migrated to Python 3. One of the most popular tools for checking your dependencies is called Can I Use Python 3? You can point it to your requirements file or setup.py, and it will analyze it to see if all your dependencies will work with Python 3. But there is a catch. Can I Use Python 3 is only checking the metadata of your dependencies. Most packages keep their metadata up to date, but some of them don't. So if you see in a report that a given package does not support Python 3, just first go and check the website of that package instead of blindly looking for a replacement. Sometimes the metadata can be wrong, and sometimes the authors of a package will create a separate version for Python 3, and they will actually link this package on GitHub. So here is how you would use Can I Use Python 3 in practice. I'm running it on one of my old projects, and I can see that there are two packages that are not updated to Python 3. It's Mechanize and Nidus. So let's check the Mechanize package. First, I check the website of the project, which in most cases is going to be GitHub. After looking around the README file, I see that indeed there are no mentions of Python 3 support. You can also check the GitHub issues to see if someone already asked about Python 3 support. Okay, so here it looks like we're going to need to find a replacement. So next place, Google, or whatever search engine you're using. I start by looking for term Python 3 Mechanize. And luckily, the first result seems to be what I'm looking for. So someone got annoyed that Mechanize does not support Python 3. So he went ahead and created another version of Mechanize that supports it. If we go to the website of this mechanical soup, it looks like it might actually be a drop-in replacement for Mechanize. And since this package is supporting both Python 2 and Python 3, we can replace the Mechanize package right now, run the test, and see that everything is working fine. So we were lucky with this package. But if you're not using some obscure dependencies, usually you will be able to find the ported versions or very similar ones very easily. So it's important to always carefully choose your dependencies, because if you keep adding random dependencies, you're going to have problems migrating them. And once you have tests and you check your dependencies, you can slowly start the migration. Don't worry, we are not going to do this by hand. Most of the work will be done with automatic tools, and then we will fix the rest by the end. So the automatic tools will do most of the repetitive work, like replacing print statements, changing the module names to their Python 3 equivalents, etc. But they can sometimes make mistakes, so you will always have to double-check their output. There is a Python module called 223 that will take your Python 2 code and convert it to Python 3. It works very good if you want to completely drop the support for Python 2. But there are two other libraries that are wrappers around this 223 library. One is called Futurize, and the other is called Modernize. Both of them will actually maintain backward compatibility with Python 2, but each has a different approach. Modernize will use a compatibility library called 6, and Futurize will use a library called Future. You can choose whatever library you prefer. Both of them will be actually a good choice. I'm not going to show you how to use both of them, as the workflow is pretty similar, so let's use the Futurize. In case you want to drop the Python 2 compatibility, you can use the 2.2.3 library directly. But here, I'm assuming that we want to take this less radical approach and make transition through the straddling code. So how does Futurize work? Well, it contains a bunch of fixes. Each fix will fix one thing. For example, there is one for the print function, there is one for has key, etc., etc. You can run a single fix by specifying its name. It will print you the changes that would be applied. And if you run it with -w parameter, it will write changes to the file. So Futurize fixes are divided in two categories, stage 1 and stage 2. Stage 1 will do the safe modifications, so all those changes that won't break Python 2.6 compatibility or introduce dependencies from the future package. And then you have stage 2 that will introduce dependencies from the future package. It will rename the standard library imports to their Python 3 equivalents and stuff like that. So you can run the whole stage of fixes at once by providing stage 1 or stage 2 parameter as the Futurize package recommends. However, I suggest that you run them one by one, especially for stage 2. So you run one fix, you run tests on Python 2 to make sure that it's still working, and then you create a commit. Also, don't mix the automatic fixes with the manual changes. If you want to fix an error that was introduced by the Futurize package, create a separate commit for this manual fix. There are 53 fixes in the Futurize package. And if you think that running them one by one is boring, then you're not the first person who thought that. There is a package called Auto Futurize that will do exactly that. It will run one fix, run tests, and if the tests are passing, it will create a commit. It's just a simple bash script, so you can either use it or just create your own version of it. And after you have run all the fixes, you have to decide what to do with strings. Futurize recommends to prefix each string with B or U, depending if it's supposed to be a byte, if it's supposed to be binary data or text. Which brings us to one of the main problems with Python 3 migration, how the strings are handled. There are many much smarter than me people who discuss this problem at a great detail, so I am not going to repeat them, especially since my approach to this problem is usually to randomly encode and decode the string until it works. So one talk I can really recommend is this one from Ned Batchelder, and it's a really good talk explaining the history and giving you recommendations for the future. One of the messages of this talk that really helps me a lot in dealing with this Unicode mess is that you should have bytes on the outside of your system and Unicode on the inside. And you should perform encode, decode at the edges of your system. It's a very simple but very easy to use and powerful idea. So you treat everything that's coming to your application as bytes, then you decode it and you store it as Unicodes in the database. Inside of your application, everything is treated as Unicode. And then when the data is leaving your system, you just encode it again. Okay, so by now, we have applied all the automatic fixes, and the test should be passing on Python 2. But they will probably fail on Python 3. So that's the last part of the migration, fixing the Python 3 code. And I don't really have any good advice here. You just have to sit down and fix all the errors. And if you prepared well to the migration and you made sure that you have good amount of tests, it's going to be much easier to find all the bugs. And then that's it. You have successfully added Python 3 support in your code. Congratulations. Now you can flip the switch on production, and hopefully everything should work fine. So finally, there are some really good resources with plenty of information that can help you with the migration process. There is a Python 3 porting book that describes the whole process of migration in a very, very great detail. There is this blog post from PySpoken blog that also tells you how to prepare to the migration, and it has a very good chapter on what parts of your application you should focus on when writing tests. And also there is a porting guide with a detailed instruction how to go through the migration process using the modernize package that I mentioned before. And finally, there are many YouTube videos that talk about the migration, although after you see a few of them, you realize that people usually have the same problems each time. So to sum up, on the contrary to what most people say, you don't have to migrate to Python 3. You can freeze your existing application in a Docker file if you're not updating it anymore. You can check out PyPy, as maybe it will work out of the box for your project. And there are always companies that will provide you paid support for Python 2, if that makes more sense from the economical point of view. But if you decide to migrate, now is the best time to do this. Those packages that were planning to migrate probably already did it. Tools that can help you with the migration probably won't get any better. They have been used by hundreds of other developers, so they are very mature, well-tested, and they contain all the necessary features. And since Python 2 is still supported by the community, you still have a few months before you will have to start fixing bugs in CPython on your servers. So do yourself a favor and convince your manager that the best feature you can add to your project is Python 3 support. And if you need help, I'm available to hire. Thank you.
Thank you for talking. Please applause for him. And fortunately, we have a few minutes for questions. Do you have any questions? Please raise your hand. No questions? Yep.
Thank you for sharing the good idea about Python 2. I'm a library developer, and is this variable for supporting Python 2 for the towards the 2000 to something years? They're using the PyPy or something, PyPy or the C Python. So I think I want to drop the Python 2 support in my library, but from these ideas and the presentation, the supporting Python 2 has some value. What's your idea or the comment?
I mean, apart from commercial vendors, I don't think anyone else is supporting Python 2. So if you're maintaining like an open source library, just drop the support. Because the website that I showed at the beginning, the one with this list of projects that is going to drop support, I mean, those are like big projects. There's IPython, TensorFlow, they're all gonna drop support for Python 2. So there's just no point for you to waste your time supporting a version that is gonna die.
Okay, thank you very much.
So you mentioned two kind of paths that you can do going from Python 2 to 3. One which is writing Python 3 compatible Python 2. So that's what we've been doing using like the 6 library in order to handle a lot of stuff. So do you think that there's any sort of different steps that you would take when you're basically migrating that way? Or do you just do the same thing and then after that just start taking out the stuff that made Python 2 work?
So actually, in my previous company, we also used the 6 library, and we did exactly the same thing. We were using 6, and by the time I was leaving the company, I think they still had the Python 2 code. They just didn't care. So I think this is a good approach. Modernize is actually using 6 as well.
Yeah. Any questions?
Okay, thank you for the great presentation. Before you stated that when you migrated from Python 2 to Python 3, please write a test that is backwards, that is compatible for Python 2 and Python 3. How do you know that the test that you write is actually compatible with Python 3 while you are still running in Python 2?
So you can use, for example, the 6 library or the future package. So there are those 2 packages that you can use, and they will provide you some functions that you can use to have like code that is compatible with both versions. And then you just use talks to run the test with Python 2 and Python 3 to see if it's working. That's the best reason. That's the best way I know of.
Okay. So, now more questions? Okay, yes, thank you so much. So thank you for a great talk. Please applaud for him. Thank you. Thank you so much.